In this video, we are going to discuss class 11th mathematics, chapter 1 sets. We are going to give you the solutions to exercise 1.3. Before that, please visit the link below for the videos on the introduction part of the exercise 1.3. The first question is, make the correct statements by filling in the symbol belongs to or does not belong to in the blank spaces. Okay. See, 2, 3, 4 is, that means, is it a subset or not a subset? 2, 3, 4 is a subset of this. Yes, 2, 3, 4. They are present in the second set also. So this is a 2, 3, 4 is a subset of 1, 2, 3, 4, 5. Second one is A, B, C, B, C, D. Is it a subset? Clearly, D is not available in the first set. So A is present in the first set and not present in the second set. So this first set is not a subset of second set. Okay. Third one, X is such that X is a student of class 11 of your school. X is such that X is student of your school. So all the students of your class are definitely the students of your school. So the first set is a subset of a second set. Now X is a circle in the plane and X is a circle in the same plane with radius 1. X, what is the circles in the plane? You can write this one. You can make a bigger circle. You can make a much bigger circle. Okay. With radius 1. X is the circle in the same plane with radius 1. Is it a subset? This is not a subset because X is a circle in the plane. All these circles does not belong to the circles with a radius of 1. So the fifth one, X is such that X is a triangle in a plane, X is a rectangle in the same plane. See, triangle is enclosing 3 sides, rectangle is, you can say, it is enclosing 4 sides. Definitely this family doesn't belong to this. So triangles are not a subset of a rectangle in the same plane, second set. So next one is, X is an equilateral triangle in a plane, X is a triangle in the same plane. X is an equilateral triangle, that means all sides are equal. X can be, the second set can be anything, scalene triangle, equilateral triangle, right angle triangle, like that. So definitely equilateral triangles are a subset of triangle in the same plane. X is such that X is an even natural number. What is an even natural number? Right? X is an integer and it goes on. So 2, 4, 6 are definitely belong to the second set also. So this first set is subset of second set. So second question, examine whether the following statements are true or false. A and B is not a subset of B and C and A. C, B and C, A and B are present in second set also. So this is a subset of second set. So the statement is false. Second one, A and E is a subset of second set. X is such that X is a vowel in the English alphabet. What are the alphabets? As you know, A, E, I, O, U. These are the vowels in the English alphabet. Clearly, A and E belong to the second set. This is statement is true. Third one, 1, 2, 3 is a subset of 1, 3, 5. 1, 2, 3, 2 is not present in the second set. This is false. So the fourth one, set A is a subset of A, B, C. Yes, this is definitely this set is a subset of A, B, C. This is true. A is a the set is a subset of A, B, C. Okay. So next one, here this set A belongs to A, B, C. There's a difference between subset and belongs to. This is belongs to. As an element, this set is present in second set? No, because there is a difference between this is a set, this is an element. So set is not in the ABC as an element. So this is false. I repeat, as a subset, this is true. As an element, this is false. Next one, x is an even natural number less than 6. What are they? Natural numbers. X is a natural number which divides 36. 1 divides 2, 3, 4, 6, 9, 12, 18. And don't forget 36. These are all the elements in the second set. 2, 4, 6 present here? Yes, sir. They are present. So this is a subset of a second set. So the answer is 2. In this example, the set A consists of 1 and 2 and 3, 4 as a set is an element and 5. These are the 4 elements in this set A. This is one element, another is this element, and 3, 4 a set. This is also present in this set A as an element and 5 is an element. So I stress again, 1 and 2 are elements and 3, 4 as a set is also an element and 5 is an element. So 4 elements are there in this set A. And elements can never be a subset. Remember that element can never be a subset. One cannot be a subset to any subset to A. 2 cannot be subset to A. Similarly, this set 3, 4, it residing in the set as a subset cannot be a subset of A. Similarly, 5 also cannot be a subset of 5. So, what is this 3, 4 within curly bracket? This is an element. Is a subset of A? No, it is incorrect. It is not a subset, but it is an element of a set A. 3, 4 within curly bracket. This is the element of set A. So this cannot be a subset of set A. So answer is incorrect because 3 does not belong to A, 4 does not belong to A, and 3, 4 is an element of A. Element can never be a subset. Now 3, 4 belongs to A. Is it true? Yes, because 3, 4 within curly bracket, this is an element in this. This is present here. So this is an element of A. So 3 comma 4, this is an element of A. This 3, 4 belongs to A. This is correct. Now coming to this 3, comma 4, a curly brackets outside is also there. This element and a curly bracket outside. This makes this as a subset. This makes it a set. So this makes this as a set. So this can be a subset of A. So this is true. 3, 4 is a set because of the extra curly bracket that becomes a set. So it is qualified to be a subset. So this is a subset of A, which is correct. Now 1 belongs to A. Yes, 1 belongs to A. 1 is an element of A. This is pretty straightforward. This is correct. 1 an element of A, 1 belongs to A. What is this? 1 is a subset of A. It is incorrect because element can never be a subset. So this is incorrect. 1 is a subset of A is incorrect because this is an element. So 1 is a subset of A. This is incorrect because 1 is an element. Element can never be a subset. So this is incorrect. Next, 1, 2, 5. Is it a subset of A? This set consisting of 3 elements. Is it a subset of A? The elements in this set, all elements in this set 1, 2, 5 are also present in set A. So this is a subset of A. This is correct. Okay. Next is 1, 2, 5. Is it belongs to A? This set as a remember this set as a whole belongs to A. No, these elements belong to A. This set is not an element of A. So this is incorrect. Understand that subtle difference is belongs to means the element. Is it present as an element? No. Here subset means this set is a subset. This subset with these elements is a belongs to is having the same all these elements are having present in this A. Yes. So this is why correct. Next one. So next one is 1, 2, 3 is a subset of A because 1, 2, 3 elements in this set are there, but element 3 as an independent element it is not there in the set A. It is the 3, 4 a set is element of A, but 3 is not a element of A. Remember that. So 1, 2, 3 is not a subset of A. So this statement is incorrect. Next one. 5 is belongs to A. 5 is what? A set. 5 will not belong to A. 5 is not present in the set A. So this statement is incorrect. The next one. 5 is a subset of A. Of course, it is correct. Why? 5 is a set. This can be a subset to any set. So this statement is correct. 5 is a subset of every set. 5 is the element or set. It is only a set. This is what I wanted to stress on this. So last question. In this 5, what is this? You should know it by this time. This is a set. The element is null set inside. So is it this element is present in A? No, incorrect. As an element, it is not present inside the set A. This I wanted to stress. 5 has 0 elements. 5 is a set and it has 0 elements. And this is a set but has 1 element. This is a set, the 1 element. The 5 is the element in this. What is the element in this? It is 5. And here 5 has 0 elements, no elements, but this is a set. Here, this is also a set. Y has one element, that is null set. Write down all the subsets of the following sets. See, first one is A. This is a set with one element A. So what are the sets, possible sets for this? First is 5. Definitely 5 is a set, subset. 5 is a subset of every set. Second one is the set itself, A. So these are the possible sets for every set. You remember that. 5 and A. Second one, A comma B. What are the possible sets? 5, A, B and AB. See, two elements are there. So 4 subsets are there. The third one, 1, 2, 3. What are the possible subsets for this? 5, 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3. How many subsets are there? Total 8. You remember I gave an empirical formula for this. When this is called the power set. The set of all the possible subsets of a set is called power set. You can refer to that in the previous videos. I described that elaborately in that. The number of subsets, the number of elements in the power set is given by 2 raised to n. N is the number of elements in the set. So here the number of elements in the set are 3. So how many possible subsets are there? 2 cube, 2 raised to 3, that is 8. You can count this. This matches with our answer. 8 elements are there, that is 8 subsets are there, then matching with this result. So how many subsets are there for 5? The subset of 5 is 5 itself, because 5 is a subset of every set, including 5. If you substitute the same thing in our formula, 2 raised to, how many elements are there in this? 0. 2 raised to 0 is equal to 1. So number of elements in the power set is 1. So that proves the answer. That proves this formula is again correct. Now comes to the next question, which is based on the interval form. Write the following as intervals. See, this is in the set builder form. X such that x belongs to R. Minus 4 is less than x is less than or equal to 6. Minus 4 is less than x. That means this is an open interval. Single parenthesis. Minus 4 and x is less than or equal to 6. That means 6 is included in this. 6 is also x is less than or equal to 6. That means s6 is included. So square bracket. This is a closed interval. This is open interval and this is closed interval. Understood? Next question is x such that x is belongs to R, minus 12 less than x and x is less than minus 10. Minus 12 is less than x. That means in an open interval. So normal parenthesis minus 12. Then this is also less than minus 10. This is also an open interval. So minus 12 comma minus 10. Both are in parenthesis. This is an open interval. Third one, x such that x belongs to R such that 0 less than or equal to x less than 7. So this is less than is equal to x is less than or x is greater than or equal to 0. That means this is 0 is closed interval. 0 is included. So we'll give square brackets 0 comma x is less than 7. So 7 is not included. Up to 7, it is all the numbers are there. 7 is open parenthesis. This is an open interval. We will give parenthesis. Next one, x is such that x belongs to R. 3 less than x. 3 is less than or equal to x. X is less than or equal to 4. Both are closed intervals. That means 3 is square brackets and 4 is also with square brackets. Square bracket 3 comma 4 with 4 with square brackets. This is a closed interval. Okay, this is a closed interval. Next one is write the following intervals in the set builder form. The opposite to what we see just now. Next one, minus 3 comma z in 0 in set builder form. So we can see this is an open interval. So you will have only less than symbol. X is such that x belongs to R. Minus 3 less than x. X is less than 0. This is in the set builder form. Second one is, this is closed interval. 6 and 12 are both points are included. So x is such that x belongs to R. 6 is less than or equal to x, less than or equal to 12. So both are included. Next one, 6 in parenthesis and 12 is in square brackets. So this is 6 is open interval, 12 is closed interval. So we'll write down x such that x belongs to R, 6 is less than x and x is less than or equal to 12. Next one, square brackets minus 23, open brackets 5. That means minus 23 is included and 5 is not included in the interval. X is such that x belongs to R and minus 23 less than or equal to x less than 5. This is in the set builder form. See, what universal set within bracket S sets would you propose for each of the following? This has a meaning in that. That means universals, you can have one universal set or you can denote more than one. That means there is a possible more than one possible answers for this. Let us see why. The set of right angle triangle, set of right angle triangles is a family of triangles are there. You can write down three-side figure. It's a scalene triangle, isosceles triangle, equilateral triangle. Like that, all the family of triangles are there. In that, it is a subset. This set of right angles is a subset of all these triangles. Set of all these triangles can be called as universal set. So the answer is set of all triangles. Now also we can see that this triangle is a part of a polygon. Polygon consists of, you can say, quadrilateral, pentagon, hexagon, like that. The list number of, depending on the number of sides, you will have different polygons. The family of all the family of polygon, it belongs to the family of polygon. So another universal set for this set of triangles is polygon. Propose polygon as the universal set for triangles. So that way you have got more than one answer for the first universal set. Similarly, the set of isosceles triangles. Here also the set of all the triangles is the universal set. We can think of that. Also the polygon is the another universal set. For this, it is similar to n belongs to z, that is integer, n also belongs to r, real number. The universal set for n is natural number is r. Also n belongs to Z, this can be considered as a universal set for this. Now, coming to the last question, given the sets A 1, 3, 5, 2, 4, 6 and C is 0, 2, 4, 6, 8. Which of the following may be considered as the universal sets or sets for all the three sets A, B and C? See this. 0, 1, 2, 3, 4, 5, 6 is. Can you consider this as universal set for all this A, B, C? Let us see. Let us examine. 135A. A is 135. 135 all present in this. 135 are present in this set. B 246. 246 are present in this set. C 0, 2, 4, 6, 0, 2, 4, 6, 8. 8 is missing. 8 does not belong to this set. It belongs to C. So this cannot be a universal set. Next, 5. 5 does not contain any element. So this is not a universal set for this ABC. Third one, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All elements of ABC are present in this set. 1, 3, 5, yes. 2, 4, 6, 2, 4, 6, yes, present. 0, 2, 4, 6, 8. 0, 2, 4, 6 and 8. All these elements are present in this set. So this is qualified to be the universal set for all these A, B and C sets. Fourth one, 1, 2, 3, 4, 5, 6, 7, 8. You can clearly see 0 is missing here. 0 does not belong to this number. But 0 is a set, is an element of C. So this is not a universal set. Hope you understood the concepts and solutions well. Don't forget to watch introduction and solutions together for each exercise. Please like and subscribe and share with your classmates and friends to get all the videos of the channel. Thanks for watching. See you then.